Enhancing retail analytic, data mining retail customer purchase pattern. Retail store could process more than 1,000 transactions every day. Just imagine, Innovaret alone, in March 2025, have around 23,000 stores. If each store, at a minimum, have a 10 transaction a day, by daily, it's already 200,000 transactions. What if for weekly, yearly? That's why this research was done. This research of data mining was done by running transaction data through anomaly detection and then market basket analysis to gain the customer purchase pattern. But what is this anomaly detection and market basket analysis? Anomaly detection is a technique that used to find a pattern that are unusual or different from normal pattern and then discarding it. Then what is market basket analysis? It is a method to find an item that often bought together. Quite classical technique in data mining. And here is the algorithm pipeline of this paper research. In this paper, I'm going to use a hybrid algorithm that combining two different algorithms to help me. First, for the anomaly detection, I'm going to use an optimal isolation forest algorithm that is an improvement of a classical isolation forest algorithm that by determining the ideal branching factor, therefore improving the isolation efficiency and bias variant trade-off. Next, for the market basket analytic algorithm, I'm going to use an ICFM-Growth or improved co-occurrence frequency matrix growth, which is proposed by Wu and Yifang at 2024. This is an improvement of FP growth, which by using a co-occurrence matrix to filter the transaction data, allowing to improve timeline. But why do I use these two algorithms and why not the basic barebone? Here, I'm gonna explain it. Here, you could see at my paper, I'm putting a three different table for the performance comparison of each MF growth versus FP growth. The FP growth here was using from this Python stock library. Now you could see at the first at 100 transaction, it takes 47 times faster for each MF growth to finish than compared to FP growth. If we want to account also for the optimal forest isolation, you could see at above here, it takes 0.06 seconds. At the 1,000 transaction, it's around 476 times faster. At the 10,000, it's 354 times faster. What does 354 times faster mean? You could see. At each MF growth, well, it takes 21 seconds plus 0.1 second for the optimal forest isolation. It's at most take 21. But if you see up the FP growth, it takes 7,500 seconds. What does it mean? In 1 hour, there's 3,600 seconds. For FP growth, it takes 2 hours. For what each MF growth take just 21 seconds. And this is just 10,000 transactions. Like I said at the beginning, in Omaret, if I have 23,000 store and the minimum a daily 10 transaction, it's already 200,000 transaction. Assumption linear, it should at least 200 to 3,000, 300 times faster. Therefore, it's gonna take a really long time. But just does it mean if it's just fast, but if not inaccurate? By comparing these three levels of difference, I gain around how many days? 96.98% accuracy of the same variable in the dataset I'm getting. Okay, now we're going to try to run the code. Okay, first let me run it. Let's skip it and just using Google Colab. Now let's using Google Colab to run the code. Okay, upload the dataset. For here we're going to using 250 transaction. Here we could see the result. It's take 0.13 second for ICFM-Growth, and how long it will take for FP growth. And there it is. It's take 11 seconds. Now we will look for their efficiency. Here's the code below to look for their efficiency. First we're going to upload the ICFM result, then the FP growth result. And we get it. We got 98.44% of accuracy. Okay, that's all for this video. Thank you everyone for attention, and if you want to try the code, you could look at the description link below. Goodbye.